How's it going, everyone? In today's video, we're going to create an AI agent from scratch, and it's going to look like this. So when we open up the Python console, we can type in something such as, what's the temperature of the sun? And using a local AI agent, it's going to be able to respond to us. We can also ask it, how do I create a for loop in Python? And once again, it's going to think. And as soon as it has a response, it's going to be able to give us back that response on how to create a for loop in Python. And we can also ask it about cooking. How do I make a lasagna? The AI will think, it will search for the response, it will try to understand what we wrote, and if we're lucky, we're going to get a good recipe for a lasagna. As you can see, the assistant gave us back that recipe. Now, the best part about this AI agent is that it's locally hosted. That means that no company is harvesting our data and that everything we write stays on our machine. The downside is, if you have a slow computer, it might take quite a bit to generate a response, because generating responses with an AI agent is considered an expensive operation. So a slow laptop or computer can take ages to generate the same response. And this is actually going to be a 3-part series. But each one of these videos will be independent, meaning you can watch the first video and it will work immediately. You don't have to wait until the third video for any of this to work. Each video will progressively upgrade the agent, giving it new capabilities step by step. And by the end, you'll have a fully functional agent that can maintain conversation history, inject dynamic context, and use tools to take actions in the real world. But let's start with the most basic version of our agent. This is the foundation everything else will build on top of. The core idea here is something called the agent loop. We send messages to an LLM, get a response back, and maintain a conversation history. It's simple, but powerful. Now, before we dive in, I want to thank Zed for sponsoring this video. Zed is a lightning-fast code editor written in Rust, and I've been using it for all my coding lately. If you want to follow along with the same editor I'm using, check the download link in the description box down below. Otherwise, let's get started. Before we write any code, we have to get our local LLM set up. We'll be using LM Studio for this video, which is a desktop application for running LLMs locally on your computer. So, head over to lmstudio.ai/download and download the version for your operating system. Once you've installed LM Studio, open it up, and you'll see a Discover tab where you can browse and download models. For me, it's this little robot with a magnifying glass. For this tutorial, I'm going to be using a model called Qwen 3.5 9B, because it's lightweight and will run on most computers. I already have it downloaded, so it's going to tell me that I can use it in a new chat. But here, if you do not have it downloaded, this button will say download. And as you can see, it's 6.5 gigabytes. So if you have fast internet, this is going to be a breeze. Otherwise, you're going to have to wait a moment to continue with the tutorial. After downloading, I'd recommend having a quick chat with the model just to make sure that it's working. So here we're going to click on New Chat, and up above we can select a model, which I'm going to select as Qwen. And here, to speed things up, I'm going to remove the Think button and say hello. And if you get a response, you've set up everything correctly. And there's one more important step. We need to enable the local API. And to do that, we need to go to the settings, and under the developer section, you'll see a section that says local LLM service, headless. And here you'll want to activate it. This will allow us to run the LLM on a local server. And once we've enabled that, we can go to the developer section, and here you want to make sure that the status is set to running. Because once again, we need to connect to the local server to grab the responses. Because behind the scenes, we are using LM Studio to generate responses in Python. And these are my current server settings, if you want to copy those. But these should be the ones you have by default. Anyway, now that we have all of that set up, we are ready to write some code. So first, let's create the agent. And here we'll use a data class to represent our agent, which gives us nice automatic initialization and type hints. Now for this script, we're going to have to use the following imports. The first one will be the requests module or library. The second one will import the data class and the field from data classes. And finally, from typing, we're going to import any. To use requests, you're going to have to make sure to install it via pip or via UV. For this example, I've already added requests via UV. And under requests, we're actually also going to import rich, because this will allow us to format text in the console quite nicely. And that also means that you need to install rich. So here I'll type in UV add rich. Anyway, once we've imported everything that we have to import, we're going to create our agent, which is a data class. And the first field is going to be a model, the one that we're using, which in this case is Qwen 3.5. Then we want to specify a base URL, which will be set to this address right here. And this is the same address that we're using inside LM Studio, where it says reachable at. Then we're going to have a field called API key, and the default will be set to no API key, since we are using a local model. If you ever decide to change to a model which requires you to provide an API key, you'll have the chance to change this later. Right below that, we're going to create a field called messages, which is going to be of type list, and that list will contain dictionaries, with keys being of type string and values being of type any. Then we can use a default factory to create that list. Right below, we're going to create a post initializer to ensure that the URL does not have a trailing slash. Next, we're going to create the chat method, and this is where the magic happens. We add the user's message to our history, send the entire conversation to the LLM, get the response, add that to our history, and then return it. This is the basic agent loop in action. So here we're going to create a method called chat, which takes a user message of type string and returns a string. And the very first thing we need to do is append the role and the contents to the messages. Then below, we're going to create the URL with the base URL and grab the /chat/completion section. And this will be used to make an API call to the local LLM. Then we'll use the following headers, which require an authorization, and this will contain a bearer with the API key if we're using an AI that requires an API key. And the content type will be set to application/JSON. Below this, we're going to create a request. And this is going to be a post request, which takes the URL, the headers, the JSON, which takes the model, and that's going to be set to the self.model, with the messages set to self.messages, and the timeout will be set to 300 seconds. Then right below, we're going to call raise for status, which raises exceptions for HTTP errors. In most cases, this should handle any issues. Next, we want to grab the data from the response, or from the request, and we want to get the choices from that data. If there are no choices, we're going to raise a runtime error, that the model response is missing some choices. Otherwise, we're going to grab the message, which will equal choices at the index of 0, and here we will try to get the message. If the message happens to be none, we're going to raise a runtime error, that the model response is missing a message. Then below that, we're going to extract the response content from an OpenAI style JSON structure, returning a default in the rare case something isn't generated and no error was given. Then we're going to add the assistant's response to our history as well, and finally return that response. Next, we're going to create the main entry point with the if name is equal to main check so that we can run some code. Inside here, we're going to instantiate the agent, and we're going to set the model to Qwen 3.5, which is the model that we downloaded. Then we create a rich console, which enables us to use BB code to style the output. This is just so we can have a prettier client. And to make things look really nice, while the agent is thinking, we show a loading wheel. We do this because depending on the model or hardware, inference can take quite some time. So, having the loading wheel gives us an indication that the client hasn't hung. And inside here, we can prompt the agent for a reply. Then below, we can print the agent's response. And with 60 lines of code, we can now run our script. And it's immediately going to use the input that we provided, where we say, hello, what are you? To generate a response. As you can see, the AI is thinking, and as soon as it's done thinking, it's going to give us a response. Hello, I'm Quen 3.5, a large language model created by this company. So everything is working as it should. And here we just hard-coded the input just to test it out. But in just a moment, I'll show you exactly how you can provide your own input in the console. Now that we've seen the code, let's break down what's happening in the agent loop. The key is that we're maintaining state in the messages list. Each time we call chat, we're passing the entire conversation history to the model. This is important because it means the model remembers what we talked about earlier in the conversation. It's not just responding to the latest message. It's responding with full context. I'm using LM Studio to run models locally, which is great for development and testing. The base URL points to localhost port 1234, which is where LM Studio exposes its API. This can be replaced with any API that imitates the OpenAI API style, which has become a standard amongst various frameworks. My recommendation is to use local models during development. They're free, fast, and you can iterate quickly without burning through API credits. Once everything works, you can easily switch to another provider by changing the base URL and API key. Let's remove this part so we can create our own custom entry point where we can provide user input. So to do that, we're going to use console print, and we want the text that says you to be green, which means that when we run this, we're going to have this little green prompt appear. The end is going to be set to an empty string, so we don't have a new line. Then we grab the user input. In most programs, you also want an exit point. So to do this, we're going to check if the user input.strip.lower is in quit or exit, then we will exit out of the program. Or to be fair, we did not create the while true loop, so we need to do that first and then paste that block of code inside here. Then once again, with console.status, we're going to create that spinner and wait to get that response back from the agent. And finally, as soon as we retrieve the response, we can print it to the console. If you're tired of the assistant being called assistant, you can also change this to something such as Bob. Now, when we run this, we can type in hello, Bob. The AI has no idea that it's named Bob just yet, so I'm kind of curious what it will respond. And it looks like the AI went along with it. What is the square root of 0? Did I spell that correctly? Yes, I hope so. Smart. How do I create a decorator in Python? And just to see how that works, I'm going to open this up a bit, scroll up, and Bob says that you can create a decorator by defining a function that takes another function as an argument and returns a new function. And then it gives us an example with triple backticks in case you want to use this in some sort of UI that formats that. So pretty much it just tells us how to create a basic decorator, and we can also ask it an important question such as, how do I make sushi? And as soon as it has figured out how to create sushi, it will give us that response. And it's quite a big response. And there are some limitations worth noting. This basic loop doesn't handle tools. The agent can only respond with text and can't take actions in the world. Also, this is all offline. It cannot search for anything online. If you try to search for some prices or for some websites, this agent is not connected to the internet. It is locally hosted and offline. So there are still many ways to improve this AI agent. Now, I do have one little tip that I want to share with you before I end this video, which will help you get a faster response from your AI. So to do that, go back to LM Studio and go to the Developer tab. Then on the right-hand side, you'll see a tab called Inference. And here you can provide a system prompt and you can disable thinking. If the model has to think, it takes much longer to generate a response, although that response might be more accurate and might have more thought put into it. Also, providing a system prompt helps you achieve the style you are looking for in your AI. And I think this works in lifetime. Speak in Italian only. And then we'll just rerun this. Hello? Yep, it updates it in lifetime, which is really cool. Anyway, that concludes the first video of this series. Do let me know what you think about this AI agent in the comment section down below, whether you have any questions or whether you'd like me to explain anything else in more detail. Do leave that in the comment section down below, and I'll do my best to get to that. But otherwise, with all that being said, thanks for watching and I'll see you in the next video.